Welcome back to this channel. In this lecture, we are going to be considering the topic practical method and techniques for solving and understanding nonlinear equations in physics. But before we continue, I want to remind you of our upcoming quiz competition live on this very channel, and it will take place by next month, 7th of September by 11 p.m. Nigerian time. I want you to be part of that quiz competition, and I also want to inform you that this quiz competition will take place every first Saturday of every new month, and you too can be celebrated as every other students and subscribers were being celebrated. Okay, so let's get started. Our first question here says, which type of graph represents nonlinear function as straight lines? Which type of graph represents nonlinear functions as straight lines? A. Cartesian graph. B. Polar graph. C. Exponential graph. D. Logarithmic graph. The correct option to that question is option A, the Cartesian graph. Question 2. In the equation y equals to ax squared plus b, what shape is obtained when plotted on a regular x minus y graph? A. Straight line. B. Parabola. C. Circle. D. Hyperbola. The correct option here is B. Parabola. Question 3. What transformation is applied to x squared equals to x prime to represent the equation y equals to ax prime plus b as a straight line? A. Logarithmic transformation. B. Square root transformation. C. Squaring of x. D. No transformation needed. The correct option is C. Squaring of x. Question 4. To straighten the exponential function y equals to a exponential ax, what operation is performed? To straighten the exponential function y equals to capital A exponential small ax, what operation is performed? A. Take the square of both sides. B. Take the natural log of both sides. C. Take the reciprocal of both sides. D. Multiply both sides by a constant. The correct option here is B. Take the natural log of both sides. So for you to straighten the exponential function y equals to a exponential ax, you have to take the natural log of both sides. Question 5. What is the result of taking the natural log of the exponential function y equals to a exponential ax? So we want to see the result. Option A, ln y equals to ln a plus ax. B, y equals to a plus ax. C, ln y equals to a plus ln ax. And D, y equals to ln a plus ln ax. The correct option here is option A, ln y equals to ln a plus ax. Question 6. When plotting ln y versus x for the function y equals to a exponential ax. What is the slope of the resulting straight line? Options: A. Ln A, B. Ax, C. A, D, small a. Correct option is option D, which is small a. The next question says, for the function y equals to a exponential ax, what represents the y-intercept in the ln y versus x plot? What represents the y-intercept in the ln y versus x plot of the function y equals to a exponential ax? The correct, okay, let me read the options here. A, Ax, B, ln A, C is A, and D is X. So the correct option is B, ln A. Question 8. In the general equation of a straight line y equals to mx plus c, what does m represent? A, y-intercept, B, slope, C, x-intercept, and D, constant term. Correct option is the slope B. Next question. Which mathematical procedure is similar to using a natural log to straighten functions? Which mathematical procedure is similar to using a natural log to straighten functions? A. Using Base-10 logarithm. B. Using square roots. C. Using trigonometric identities. D. Using polynomial expansion. The correct option here is option A, using the Base-10 logarithm. Question 10. To determine the slope and intercept of a linear function. To determine the slope and intercept of a linear function, the nonlinear equation must first be A. Differentiated, B. Squared, C. Transformed, D. Integrated. Correct option to that question is option C, transformed. So to determine the slope m and intercept c of a linear function, the nonlinear equation must first be transformed. That's how far we can go for this lecture. This is our Gmail. So if you want to message us, you message us through that Gmail. This is our home page. I want to say thank you to everyone who have watched this video, and to our subscribers, I would still encourage you to like our video. And those who are yet to subscribe, I would like you to try and click on the subscribe button. When you do that, it will appear to be subscribed. So whenever we have new notifications, you would be updated. Thank you for watching. Have a wonderful day. See you in our next lecture. Bye.